Probably. We'll see. All right, so we are going to talk about exponential graphs and transformations. So we're going to bring back all those transformations we talked about with the left shift, right, up, down, vertical stretch, compress, reflect, all of those things that hopefully you know really well by now, but we're going to apply them to exponentials. Before we get into that, I want to talk about what an exponential is and kind of identify the initial value in the base. So let A and B be real number constants. An exponential function in x is a function that can be written in the form of y equals a times b to the x. So an exponential is going to have x in the exponent. Right, x is in the exponent for something to be exponential. A is going to be your initial condition. And B is going to be your base. A cannot be 0. B is always positive. And B cannot be 1. And those are just conditions because if A was 0, anything times 0 would be 0, and it would just be 0, which wouldn't make sense. And 1 to any power is 1, so that would also not really give you an exponential function. So those are just conditions that are going to guarantee that that guy is exponential. And then I already talked about A is going to be the initial value. So kind of like the y-intercept, but not really. And B is going to be your base. The base is going to tell me whether my function is a growth or a decay. That's all the base does. So the base isn't really a transformation. It tells me what kind of exponential I have. All right. Down here, we're going to identify the initial value, the base, and whether or not my function is an exponential. The base is the guy that has the exponent. So whatever's getting raised to something, that's a base. So on this first example, what would the base be? 2. Because 2 is getting raised to x. The initial value is the guy in front of the base. So what is the understood number in front of 2? 1. And is this 2 to the x, is it an exponential? Yes, because x is in the exponent. All right, on the second example, what would the initial value be?
4.
4. What would the base be? X. And is this an exponential?
No.
No, because x is the base. It's not in the exponent, so not an exponential. All right, on the next one, what would your initial value be? 5. What would the base be? E. So E is the guy that's getting raised to the exponent. And is this an exponential?
Yes.
Yes, because x is in the exponent. It also has a negative, but that's okay because x is in the exponent, and that's what I care about for an exponential. All right, on the next one, what's the initial value?
3.
What is the base?
4.
And is this an exponential? No, because that's an E, not an X. And then the last one, what is the initial value? -1. What's the base?
5.
And is this an exponential? Yes. All right. So there are some attributes of exponential functions that we are going to graph. So today is going to be all about graphing. The first thing you're going to graph is the horizontal asymptote. All right, the horizontal asymptote is going to be the very, very first thing you graph. Since it's horizontal, the only thing that's going to affect my horizontal asymptote is an up-down shift. All right, where is your up-down shift located in your function? Outside, inside?
Outside.
Outside. So the up-down shift, which is on the outside, is going to be your horizontal asymptote. So what this would look like, a times b to the x plus d, whatever this guy here is, whatever's being added or subtracted on the outside is your horizontal asymptote. All right. If there is no number there, where would your horizontal asymptote be? At 0. Hello? Yes. Alyssa, go see Miss Harvey. She said it was going to be fast. Okay. So the first thing you're going to graph is your horizontal asymptote. The next thing you're going to graph is going to be your initial condition. All right, so your initial condition, which if you're like a formula person, this is the formula for your initial condition. All right, so the x value is only going to be affected by your left-right shift. That's it. All right, so it's either going to move left or right. That's all that the x value will shift. The y value, which is a little bit more complicated, is going to get stretched or compressed, whatever your a value is, which is the very, very front number, right, the initial number there. So whatever the stretch or compress is, and it's going to get the up-down shift as well. So both of those are going to affect the y value of your initial condition. All right, so normally, we're going to ignore this negative here. So cross off this negative. So this is a parent growth function. We're going to take the negative out. We're just going to do the parent growth function. Your asymptote's at 0. Your starting point is going to be right here at 1. And if you grow, you move away from your asymptote. All right, so if you are growing, you move away from the asymptote. So from left to right, you're getting away from the asymptote. So when we are shifting this point right here, if it's getting vertically stretched or compressed, it's going to be that much away from this asymptote. So normally on the parent function, it's 1 box away. Does that make sense? If it gets vertically stretched by 2, it'd be 2 boxes away. If it gets vertically stretched by 5, it'd be 5 boxes away from the asymptote. All right, 1/2 would be 1/2 away. Aside from that, then you just have to think about your left-right shift. That's the easiest way to do that, but we'll do some examples and I'll show you that. So this is what the parent function of a growth looks like. All right, so we're going to draw the parent function of a decay, which asymptote is still going to be at 0. Unless there's an up-down shift, yeah. The decay starts away and it goes toward. You are still going to cross at 1, though. So my graph got a little messed up. I'm sorry, I got to fix my notes. But asymptote's at 0. The decay starts up and it goes toward the asymptote. So you've got 2 types of parent functions. You've got a growth and you've got a decay. So the growth starts toward the asymptote, moves away from it. The decay starts away, moves toward the asymptote. All right, so I'm not going to do all of these. It takes too much time. But I do want you to write that part down, that the growth is going to move away from your asymptote, and the decay moves toward. Is that okay? All right, so on 14. Is this guy a growth or a decay? Growth. What about on 15? Decay. What about on 16? Decay. It's underneath because it got reflected, but if you go from left to right, it's going towards your asymptote, so it is a decay. What about 17? Growth. Also got reflected, but from left to right, it is moving away from the asymptote, so it is a growth. It is growing negatively, but it's still a growth. Does that make sense? Okay, so now we're going to graph. All right, so we're going to describe the transformations, and we are going to graph. Now, on all of these guys, my base is going to be 2. All All right, so we're going to start off easy. We're not changing the base. Since the base is 2 on these 4 examples, is that going to be a growth or a decay? Growth. All right, so on these 4 examples, we are transforming a growth function. All right, first thing I'm going to do is the asymptote. On 18, is there any number getting added or subtracted outside? No. So where is your asymptote going to be at? 0. Because technically it's like plus 0 out there. Okay, now for your starting point, which normally your guy's going to start right here at 1.
It's going to go up.
But you got to think about your transformations. So we don't have any up-down shift. What is that plus 1 going to do? Left. All right, that plus 1 is going to move it to the left one. So normally when you're starting at 1, we're actually going to move to the left. So your starting point's going to get moved left 1. And then all of these guys are grow, so we're going to start toward my asymptote, and we're going to grow away. So when I grade your graphs, I'm going to look for 3 things. I'm going to look for the asymptote, I'm going to look for this starting point right here, and I'm going to look to see, are you growing or are you decaying? That's it. So we're not going to get any more particular than that. So 1 point, the growth or decay, and the asymptote. Okay, so let's look at 20. On 20, where is my horizontal asymptote going to be? At 2. Because of the up 2 shift right there, which I'm going to write that here. All right, so that plus 2, that is your horizontal asymptote. It got shifted up 2. Normally it's at 0, but it's getting shifted up 2. Okay, so now let's talk about the initial condition point. And there's a couple ways you can think about this. On your initial condition, are you shifting left or right any? No. So I know it's going to be somewhere on the y-axis here because it's not going to go left or right any, so it's going to be at 0. Normally it's going to be 1 above the asymptote. All right, so normally you're 1 away from the asymptote, but because I'm vertically stretching, how many away am I going to be? 4. So above your asymptote, you're going to be 1, 2, 3, 4. Because you have a vertical stretch by 4. Now, if you think about all your transformations together, it makes sense. Because normally you start at 0, 1. Right? And we got shifted up 2. So 1, 2, and we got stretched by 4. And so it makes sense that you end up there at 6. Because you got stretched by 4. So 1 times 4 is 4. And then you moved up 2, which would bring you to 6. And then this one here is a growth, so we're going to start near the asymptote and we'll move away. Is that okay? All right, go down to 19. Where's your asymptote at on 19?
0.
At 0. All right, what kind of transformation do I have going on here? Reflect over which axis? Over the y. All right, because it's inside. So it's not a reflect over the x. It's not a normal kind of reflection. It's a reflect over the y because the negative is inside with the x. Now, is my initial point, is it going left, right, up, down, or anything like that? No. So my initial point is going to be here at 1. All right, it's not going left or right or up or down. It's not flipping over or anything like that. So far I haven't done anything with this negative. So what this negative is going to do is it's going to make your growth look like a decay. All right, so even though 2 is bigger than 1, and this is a growth function, that negative is going to make it look like a decay. And so we're going to start away from the asymptote and go toward it. So if you have a negative inside the exponent, it changes your growth or your decay to be the other one. That's what the negative inside does. If the negative is on the outside, and we're going to do an example like that, all it does is it flips it underneath the asymptote, and that's it. The tricky thing is the negative inside changes your growth to a decay or your decay to a growth. All right, so same thing here. Where's your asymptote going to be at? 0. Your initial condition, left, right, up, down, any, are we shifting, going anywhere? Nope, it's going to stay right here at 1. The transformations, I'm reflecting over the y, which is going to turn my growth into a decay. All right, so that negative inside is going to turn my growth function into a decay. The 2 is technically a horizontal compress, but since we're only plotting that first point there, we don't need to worry about the horizontal compressions. It is a transformation, but it's not going to get graphed. So we just need to make this growth into a decay, and then we're done. Wow, I missed my point completely. That's okay. All right, y'all ready to try to graph some other ones? Okay. So on 22, we're going to start with the asymptote. -2. Then we're going to do our initial condition. So our initial condition is going to be 1 away from your asymptote, right? Because there's no stretch going on. All right, so I know it's going to be around here-ish. Is it getting shifted left or right any?
Yeah.
Which way?
It's going to go left.
Right.
Right.
Is minus?
Oh, it's...
So this guy here is down 2. This guy here is right 1. So normally you start at 1 here. You go down 2, right 1. Or I'm sorry, down 2. Right down 2, right 1. I said it right. So your little point would be like right there. 1 away from the asymptote, which makes sense, and getting shifted to the right 1. Is that okay? All right, the only other thing I have to worry about is growth or decay. So what is my base?
3/2, which is 1.
So it's a growth, so we're going to start close, move away. So looking at your graph, is it increasing or decreasing? Increasing. And then for the end behavior, as you are going to the right, what is your function doing?
Positive.
As you're going to the left, what's your function doing? Going to -2. Because it's not going down forever, it's stopping right here at -2.
Is it okay if we write it like that?
Yeah. All right, hop over to 24. Okay, start with the asymptote. Where's that at?
Up 3.
Up 3. What other transformation do I have going on?
Up 3, left 1.
Right 1.
Right 1.
And what's this negative sign going to do?
Flip it over the X.
Flip it over the X. So it's going to reflect it, which means since it's on the outside, all that happens is that instead of your exponential being on top of your asymptote, it's underneath it. So all my stuff is going to be happening underneath my asymptote. Because it gets flipped. Does that make sense? All right. The A value is still going to be 1 away. It's just going to be 1 away underneath the asymptote. All right, so it's still going to be 1 away underneath because there's no vertical stretch or anything. And then we are going right 1, so it'll be right there. All right, it's still 1 away because there's no vertical stretch. It's underneath because of the reflection, and it's getting shifted to the right 1.
So the E, does that do anything?
It's going to be our base.
Okay.
And then because it's E, which is 2.7 something, is that a growth or a decay? Growth. So that's all it tells me is whether I'm going to draw a growth or draw a decay.
And then when the exponent is negative, does that actually flip whether it's a growth or a decay?
Mm-hmm.
Okay.
Yep.
Why is it at 2 instead of 1?
This guy?
Yeah.
So it's going to be, you want to be one box away from your asymptote, and it's underneath because of the reflection, and then shifted to the right one. And we're going to grow, so we're going to start towards your asymptote and then grow away from it. So are we increasing or decreasing? Decreasing. And for your end behavior,
X going to negative.
yep, exit as x approaches, the right side is going to negative infinity, and the left side is going to 3. Okay, go to 25. All right, so where's your asymptote at?
2.
Up 2, yep. All right, so let's look at the other transformations. What else do I got going on?
Up 2, left 1.
Up 2, left 1, and
Flip X.
flip. So is your exponential going to be above the asymptote or below the asymptote?
It's going to be below.
Below, because it got flipped because of that negative transformation. All right, so my starting point, it's going to be below. It's going to be 1 below, but it's going to get moved to the left. So my initial condition is going to be right there. 1 away from the asymptote, but to the left one. Okay, the base. What would the base be?
Decay.
It's 1/4, which is a decay. So decays are going to start away and then go towards your asymptote. So it'd be increasing. And then as x approaches infinity, f of x goes to 2. And as x approaches negative infinity, negative infinity.
Why is it increasing if it's decay?
Because it got flipped.
Okay.
So if you kind of think about like the decay is a negative, the flip is a negative, a double negative is positive, and it kind of makes it increase. We're going to skip now 23, but I want to go do 26 and 27. All right, so where's my asymptote on 26?
0.
At 0. There is no up, down, shift. And then what other transformations are happening in this function?
Flip over the Y.
Flip over the y, which isn't going to change it's going to change the growth decay. That's all it's going to change. It's not going to change your starting value, your horizontal asymptote, or anything like that, but it is going to make our growth and decay to be the opposite. So my starting value is still going to be just 1 away on top because there's no reflection over the x. Does that make sense? Okay, so now we got to talk about growth and decay. So my base is what?
0.5, so it's decreasing this since you flip it.
Yep. So 1/2, which is less than 1. So normally I would say that's a decay, but because I'm flipping over the y-axis, that's actually going to turn that into a growth. So we're going to start close and we are going to grow away, which makes us increasing. And so as x goes to infinity, f of x is going to go to infinity. As x goes to negative infinity, f of x is going to go to 0. All right, go to 27. Where's your horizontal asymptote on 27? Negative 2. Yep, we went down 2. All right, what other transformations do I got going on?
Flip over the Y.
Flip over the y, which isn't going to change anything except for my growth decay. Oh my gosh. I'm just going to say flip y. All right, so my starting point is going to be 1 away from my asymptote. It's going to be on top. All of that stays normal. What is my base?
3.
3. So normally I would say that's a growth, right? But because we're flipping over the y, we're going to draw it as a decay. So we're going to start away, go toward, increasing or decreasing?
Decrease.
Decreasing. And as x goes to infinity, f of x is going to go to.
-2.
And as x goes to negative infinity, f of x is going to go
Infinity.
to infinity. All right, so we can kind of pull some information, not all of it, but we can pull some information given a graph. So the graph at the right can be modeled by the equation a times b negative x plus c. Complete the following. All right, so the important thing here is that there is no left or right shift. So this guy right here is my starting value.
Yeah.
Because it doesn't have like anything up there with the exponent. All right, so the other thing is I've got an a value. So let's think about this a value. Because my graph got flipped under the asymptote, what's special about my a value? It's negative. Yes. All right, so I know my a value is going to be negative. And we can't exactly say what negative number, but we can kind of guesstimate. So about how far from the asymptote would you say it is?
0.5.
0.5. Sure, we'll go with that. So we'll say a is like 1/2. All right, and that's just guesstimating, but remember, normally your a value is 1 because it's a distance of 1 away from your asymptote. In this case, your asymptote to your next point is like about 1/2-ish. So we're guesstimating that a is about 1/2. All right, the b value is a growth or a decay. So we can't figure out what b is, but we can say whether it is bigger than 1 or a fraction that's less than 1. So is this function a growth or a decay? Is it moving away from the asymptote or toward the asymptote?
Away.
So it's a growth. All right. So if it's a growth, what has to be special about b? It's bigger than 1. But look at your equation. What's special about your equation? Yes, it's got a negative, which is going to be flipping it. So really, b is going to be a fraction less than 1. Because of the negative that was given. And then what is the c value? We can actually determine what the c value is. 2, because that c value is the horizontal asymptote. All right, so no way to figure out what the b value is. All we can say is that I know it's going to be less than 1 because I know this is a growth. The negative flips it to be a decay. Decays have to be less than 1. We can do, and so the graph is a growth, so away from asymptote. For the end behavior, the limit as x approaches infinity of f of x is going to be what?
-infinity.
And as you approach negative infinity is going to be
2.
perfect. All right, we are going to skip question 29, and I'm going to take off those on your homework too. We're not going to do that. It's not on your final. But I do want to look at the table. All right, so when we're looking at the end behavior of this graph, and this is my last one, and then I'm done. As x is going to positive infinity,
It's going to 2.
it's going to 2. G of x is going to 2. So you see as the right side of my table here, do you see how my numbers are slowly approaching 2? The y numbers? It goes like 3.25, 2.47, 2.00. And then the left side of my graph,
It's going to
infinity. Yeah, the numbers are just getting really giant. It goes 17, 92, 487. So they're not really approaching anything. They're just getting really, really big. So knowing this about my end behavior, what can we say the horizontal asymptote is?
2.
2. Because the graph levels off at 2. since my asymptote is at 2, what would the value of C be? 2. Because the C right here. All right, and then what conclusion can be made about A? So the left side is going up, the right side's going toward your asymptote. So is it a growth or a decay?
Well, it's flipped.
It's a decay, but it's flipped. So the A, oh wait. Oh, the A value. Okay, so the A value, actually, I'm sorry, thought it was asking about whether it was a growth or a decay. The A value just depends on, are you above the asymptote or below the asymptote?
You're above because you're going positive.
Yeah, you're above because your numbers are positive, they're bigger than 2. So what does that mean about A?
It's positive.
It's positive. So there are some things that we can pull from the table, knowing how to find, the A value and the growth and decay and the asymptotes and things like that. Does that make sense? Is that okay? Okay.
So what questions are we taking?
Let me look and see. Describe. That's fine. Um, 17 and 18. Or wait, no, it's that's fine. We can take off 17 through 20. I think the rest of them we can do.